Hello. In this video, I'm going to be talking about how we can interpret Probit and Logit models using marginal effects, and also how to do that in R. So if you remember in the last video, I showed you this table of coefficients from a linear probability model, a Logit model, and a Probit model. We saw that it was a little difficult to interpret what was going on with the Logit and Probit coefficients. Now you can interpret these coefficients directly if you really want to. There's odds ratios involved and a lot of stuff, but it's a lot easier if we can put things in terms like the linear probability model has it. What is the effect of a 1 unit increase in X on the probability that the outcome is equal to 1 as opposed to 0? So we can do that with the concept of marginal effects. And really what we're trying to get here is what is the slope on this prediction line? But that's it. What's the slope on that prediction line? That's what the marginal effect is. And mathematically, you can think of this as being a derivative. If we took the derivative of our Probit or Logit function, then it would give us the marginal effect, of course. Now, the difficulty here is that the math here gets a little bit tricky, and that's true for both the Probit and Logit. I can tell you that for Logit, for example, the derivative of the logistic function is whatever the coefficient is on your variable times the value of the logistic times 1 minus the value of the logistic. That's the marginal effect. But you probably don't want to memorize that. But the key thing to look at here is first of all, as we mentioned last time, the marginal effect is going to differ depending on what the index function as a whole is. It's not just the coefficient by itself, but it's the coefficient multiplied by this function of the index function. So the slope on your x variable is going to be different depending on what the prediction for you already is, what your index function already is, right? And this makes sense, right? So we would expect, if you're somebody who's down here, then your slope should be pretty flat. If you're somebody who's up here, then your slope should be steeper. What we can take away from this is that each individual observation in your data is going to have a different marginal effect based on what their index value is, right? So this is not exactly the same as what we talked about in the interactions video, where I said that, the effect of a variable could be different for like different groups or things like that. This is not so theoretically fundamental or anything like that. What this is saying is that the marginal effect is going to be different depending on what your index value already is. Because if you're down here, you don't got much room to move. If you're up here, you have a lot more freedom. It's not that there's some fundamental reason why it might be differently effective for you or me. It's just where did we start? It's going to tell us about how much more room we have to move. So we have a different marginal effect for each individual observation in the data, depending on what their index value already is. Are we predicting that they're in the middle, in which case they're going to get a steeper marginal effect? Are we predicting that they're near the edge, where it's going to be shallower? So given that each individual has their own marginal effect, how can we say there's such a thing as a marginal effect, right? That if we increase x by 1, then this is what's going to happen generally, as we would want, right? That's going to be the simplest way of interpreting what's going on here. We could, of course, just calculate the marginal effect for each person and show you the distribution of those marginal effects. That is something you can absolutely do. That is the cleanest and most thorough way of showing a marginal effect, but that's often not what we want. Often, we want to have a single number that represents the marginal effect for the sample as a whole, and then we can also put, for example, like a standard error on that and see if it's statistically significant or not. Now, there's a couple of different ways we can take that distribution of marginal effects over the whole sample and boil it down to one number. There are three main ones. So one is to get the marginal effect of a representative, and that is to pick a set of values for an individual and say, I want to know what the marginal effect is for the person who has those values. And that actual person may or may not actually be in your data, but you can ask something like, okay, I want to get the marginal effect for a woman who is 22 years old and has red hair and da-da-da-da-da, right? I can plug in all those values, see what the index function is, and then use that individual index function to calculate an individual marginal effect. And that would be the marginal effect of a representative. I can also get what's called the average marginal effect. That is calculating the marginal effect for each individual in your sample and then just averaging it up, and that's your average marginal effect. You can also get what's called the marginal effect at the mean. What that is that you first calculate the mean of every single one of your independent variables, and then you use that to get the marginal effect of a representative. And so in that case, your representative is the person with the average values of each of your independent variables. This one used to be a lot more common It is less common now. Now I'd say the default expectation is probably the average marginal effect. The marginal effect at the mean is a bit easier to calculate because you only need to calculate the index and then the link function once. But also it means that you're getting the marginal value for a person who doesn't actually exist. Right? I mentioned trying to get the marginal effect for somebody with blonde hair. Well, if 25% of your sample has blonde hair, the marginal effect at the mean will calculate the marginal effect for a person who is 25% blonde. Right? That person doesn't exist, so it's kind of weird. And it also ignores how the different variables might be related to each other. So at the mean, you might predict somebody's going to be right in the middle and get a very large marginal effect. But if everybody in your sample is actually way over here or way over here and nobody's in the middle, well, the real marginal effect is almost zero for everybody, and yet we'd be giving them a large effect. So probably the standard of what you want is the average marginal effect to get the marginal effect for each individual in your sample and then average those out. So let's see how we can do that in R. So I'm going to load up some data. So I've got the Wooldridge library, which I'm only using to get this data set, the card data set. If we look down here, what do we got? So we've got a bunch of indicators here. And what we're going to be predicting is whether you enroll in college in 1976, based on some things like how close you live to the college, your parents' education, and I think I'm going to throw in your IQ score there as well. So let's just show just how to do Probit and Logit and linear probability models in R. So first of all, linear probability models, that's easy. We've done this before. It's just regular regression. So our LPM, it's going to be the regular linear model. We're going to regress enrollment on being near a college. That's 2 years. Being near a college, that's 4 years. Your father's education, your mother's education, and then also your IQ score. And that's from the card data. And there we have it. We have our linear probability model right there. Okay, so now let's do it with Probit or Logit. This is actually fairly easy to do because all we need to do is take this exact same code. And as I mentioned, we're doing a generalized linear squares. So let's just do that. So our Probit is going to be using the GLM, generalized linear model. And we're going to do the exact same formula, the exact same data call. But the only difference is that we need to tell it what kind of link function we're going to use. So we're going to use the family. It's going to tell us what kind of family of link functions we're using. And we're going to use the binomial link function, which is for binary data. And we're going to say our link is the Probit link. And that will run Probit for us. Logit is the exact same. Just instead of doing a Probit link, we just use a different link function. We just use the Logit link. And we can run that. Let's look at all of these regressions together. So let's load up the JTools package, and let's do export sums, LPM, Probit, and Logit. Let's see what that gets us. All right, so not a lot is significant here, but living near a college, four-year college, certainly seems to have an effect on whether you enroll. The coefficients, of course, are not easy to interpret because they're just Probit and Logit coefficients, but we get a linear probability model effect of about an increase of 4 percentage points in the probability of enrolling, with one significant star, which is at the 5% level. Okay, so how can we get marginal effects from this? So there's actually several different packages. I mean, as with everything in R, there's a bunch of different ways to do it. Probably the most common way to get marginal effects is with the MFX package, which contains the Logit MFX function and also the Probit MFX function for getting marginal effects for those models in particular. I prefer, however, the margins package, because what this does is a couple things. So for one thing, it gives you average marginal effects by default. That's nice. For another thing, it gives you the marginal effects for all the variables by default. Also nice. For another thing, it works with both Probit and Logit for the same function. So instead of a Logit MFX and Probit MFX, it's just margins as the function. And then lastly, it properly deals with, in my opinion, it properly deals with things like interaction terms. So we have an interaction term in a Probit or Logit function. We want to get the marginal effect. Well, what we're really saying is, okay, great. I know that the effect is different for these different groups because I've included an interaction, but I want to know the average marginal effect. So what is the effect of this variable for you? That will already incorporate the interaction term in there. So any interaction terms I include in my Probit or Logit model are going to disappear using the margins function, which probably makes a lot more sense for calculating the average marginal effect. Now, that said, there are some ups and downs. If you use Logit MFX or Probit MFX, you will indeed see the marginal effect of the interaction term, which might be good if what you're interested in is getting the significance of your interaction term, although you want to be careful with using interaction terms and interpreting them in Probit or Logit models because they don't always mean what you think they mean. See the slides, I talk about this, or look at Ian Norton 2003. So you might want to use MFX for that reason if you're interested in the interaction term. The other thing about margins is that as of this filming of this video, it doesn't work with export sums unless you install the development version of the Broom package. So if you want to use this, if you're watching this in, let's say, 2021, you probably don't need to bother with this step. For right now, you need to do remotes, install GitHub tidy models Broom. I'm not going to run that because I've already done it, but that will install the development version of Broom, which is necessary to use the margins output in our export sums thing. If you don't have, you might also need to install the remotes package before you do that. Okay, but we've already done that, so let's do margins. So we've loaded up the margins package, and I'm going to do my Probit margins, and all I got to do is margins of Probit. Done. And I'm going to do Logit margins. And I'm going to do margins of Logit. There we go. And of course, there's a number of different options there. If we look at help margins, where we can specify margins at different variables, at different values. We can choose all sorts of stuff. You can choose whether you want to get the marginal prediction or the marginal value of the link function. So do you want to get the coefficient inside there? Generally, you want the response if you're going for marginal variables. We can see the output here, export sums, LPM, Probit margins, and Logit margins. Look at that. You do get this little arrow down here, but don't worry about it. So we can see here that now the results are all very similar. I promise I did not just put the OLS result in there multiple times. This is the marginal effect. It just so happens that here the OLS, the linear probability model, seems to do a pretty good job of mimicking Logit or Probit anyway. We get a 0.04 percentage point bump in our enrollment rates for living near a 4-year college. Other thing to point out with margins is that we can get the marginal effect for a representative, right? We can choose a marginal effect either by setting all of the covariates to particular values or just setting 1 or 2 of them to see. And what that does is it says, okay, what would the marginal effect be if everything else was the same, but everybody had this value of this variable? And that's going to determine where we are in the index, and that's going to give us a different marginal effect. Now, to be clear, this is not getting the effect among that group, as we might do if we were getting some sort of interaction term. It's just saying, let's set this value and see how that affects the index. And then just based on the changes in the index, what are the marginal effects there? So we can do that with the at option in margins. So let's say Logit at. That's going to be margins of Logit. And let's say we're going to set at. And here we're going to set a list of options. And let's say that your IQ is 110, let's say. And if I do this, I now have the marginal effect just as though everybody had an IQ of 110. And we can see the result there. That was not enough of a change to really change the result, but that is how we could set values, different variables to different values, and then calculate the marginal effects from there. All right, that is it. Thank you very much.